Everyone, this lecture is about set and map. Set and map are two of the interfaces that are very frequently mentioned and used in the Let's go ahead and start with sets. So as you can see here in this slide, this is basically like that kind of small picture of the different interfaces and the classes implemented. As you can see, we have uh, an interface called collections. What? And then under collection, we have a list. That's an interface that extends collection. And the classes that implement the list interfaces like array list, linked list that we're going to be learning next under vector. Now we have also sets, which also extend the collection interface. The classes that will implement the set interface are mainly like the HashSet and the TreeSet. But the main difference is the order. The TreeSet will store them in a natural order. The same thing for the map, so that's an interface, and then we're going to be discussing the two classes that implement the map interface, which is the hash map and the tree map. And again, the main difference is that the elements are sorted in natural order for the tree map. All right, well, let's go ahead and get started with HashSet and TreeSet. So this table shows the main differences between the two. So as you can see, the HashSet, the main characteristic of a set, regardless which one you are using, HashSet or TreeSet, is that they don't accept duplicates. That's the main reason we choose this type of classes. So the HashSet uses hash map internally to store its elements. The TreeSet uses tree map internally to store the elements. A HashSet is an order, so basically it looks like a random order for us. And the TreeSet orders the elements according to supplied comparator, whatever the case may be. So if no comparator is supplied, elements will be placed in their natural ascending order. So if you have numbers, they will be sorted in ascending order. If you have string, they will be sorted in alphabetical order and so on. Now, generally speaking, well, most of the time, HashSet is way faster and more efficient than TreeSet. So if there is no reason to choose TreeSet, the best choice is to use HashSet because it's way more efficient. All right. As you can see right here, we said that TreeSet and HashSet are the most popular implementation of the set interface. Okay. And then the HashSet and TreeSet won't maintain insertion. So let's go ahead and let's use an example. Here it says use TreeSet if you want to sort the elements according to some comparator. As I said, if the reason is, if the order is not important, so it's better to use a HashSet. So let's switch to Eclipse, so we can have some examples how we declare and initialize the HashSet and TreeSet. So let's start with the HashSets. So this is how we declare them. Then we specify the class or the type, the data type. So for example, integer, and then we're going to call it mice. So HashSet integer. So here the size is empty. When you create a HashSet object for the first time, so you can see right here, if I print the size by set size, it will say 0 because that's the pattern. All right, and then also when you check if it is empty or not, you can check if the set is empty or not using the method is empty. So since there is no element, it's going to say true. Set is empty. And then you start adding elements. So I'm going to put something here using the method add. So we can add, for example, some numbers here. And then you can add 12 bisects and 3. So now when I want to print the hash sets, bisects, since we are using the hash sets, we can expect any order, like this random order. You can see right here 3, 9, 12, but it could be in any order. Okay, it doesn't have to be in order. Now I want you to pay attention here. If I try to add an existing element, let's say you want to add 9. So 9 already exists. So if I try, so it's going just to ignore that number. Why? Because we already have that. And then if you try to print, because the add method is a return, the method is going to return either true or false, depending whether the number already exists or not. So I'm going to put, for example, my set add 9 and then close this. So if I run the program here, it's going to show me false. Why false? Because 9 already exists. So basically, it's like saying that the addition, the operation of addition was not successful. I was not able to add 9 because there is already 1 in this section. But if you print 3, for example, here, so since 3 is not in the set, it's going to say true. That means the addition was successful. Okay? So it says true for 3 because there is no 3 in the set before. We have only 9 and 12. So the addition was successful. Now the next question, how do we print all the elements of the order? And by the way, you can remove any element. Let's say, for example, I want to remove 12. So you can remove it. Then I will print the set after to see what's going to happen. So I remove 12, so now 12 is not in the set. Okay, we have only 3 elements. So let me add a few numbers, and then I will show you how to print the entire set. There are different ways you can do it. So my set, let's say 2, my set 16, my set 8. So now let's print and then see what is the state of the set at this point. So now we have how many? We have 4, 5 elements. As you can see, look at the order. It's totally random. It looks like a random for us. 16, 2, 3, 8, 9. There is no order here. Now, how do we print the elements of the set? So we have different ways. So one way is using the for each loop. The for each loop works pretty much with all the data structure. So we can say, for example, for every element, so since we have integers, so we're going to put for every number in the set, then print system I print now the little space. So this will print the elements of the message 16, 2, 3, 8, 9. So that's one way of printing. The second way, so let's skip line. And then the second way is using iteration. So the iterator basically is just like an easy way to access and cycle through the collection or whatever data structure we are using. So first one, we have to create the iterator. So create an iterator object. So here we have integer. We're gonna call the object int, and then the name is my set, and then you call the method iterator. And it's going to act pretty much very similar to iterator. It's missing A. And then it's going to look very similar to the scanner. I mean, if you are familiar with the scanner, you're going to see it's almost the same method. Next, has next. So we're going to use the while loop, while next. That means as long as there is an element to be processed, do the following. So we are going to print. So print X, and we call the method next. So every time we call the method next, we access the element and move on to the next until there is no more to be processed. So then let me just space here. I'm sorry, if we said here print 8 next, yes, I can just put plus and then space. So now if I run the program, it's going to show exactly the same thing, 16, 2, 3, 8, 9. And then, yeah, so there is more than a way to print the element. Or you can check, for example, here, if the number is positive. So you can use the F statement inside to check if it needs to be. So this is pretty much how the set works. So in the next lecture, we are going to talk about the hash map and the tree. Before I forget, okay, we didn't talk about the tree set. So for example, for the tree sets, the only difference is so we're going to create is the order. Declare and initialize a tree sets. So let's create one tree set. This should be stamp string. I'm going to call it TSet, TS equals new tree set string. And then I'm going to add element. Now here, the order will be respected, whatever that normal or a natural order is. So TS add, let's put names in. Let's say David. And then we have TS add, okay, Mike. TS add, let's say Bob. So here we have the first level is capitalized. So TS, then we can add, for example, Steve. So now when I print system out for imply TS, so it's going to be in the alphabetical order because that's the natural order. If I run the program, you can see that it is, look at the first letter, Bob, B, D, M, and S. So that's the natural order. There's also something important we need to mention is when we have a relationship, what kind of relationship we have between the sets. Like for example, if you have 2 or 3 different sets, HashSet or TreeSet, then you can perform some kind of operation, like find the union combination of 2 different sets, or the intersection, or the difference. So let's have an example about this. So let's say we have TS1 is the first set. So I'm going to put, let's assume that this is a class. So this class has the following food. Okay? So TS1 S1, TS1, and then this is TS1. So this is the first class. It has this. Okay? Now let's create another class. String set string TS2. New TreeSet. And then the second class has the following students. So let's say we have Maria, and we have, say, Jasmine, TS2, and then also they have somebody called Mike, but that's a different Mike than the one we have in TS1. And then no, I'm sorry. It's the same mic. It's the same mic. It's just taking two classes. Yeah. So this mic is the same. We don't want to create confusion here. So Mike is the same guy in TS1. It just happened that he's taking both classes. Okay. So then we have, let's say, another person. Let's say, uh, John. Okay. And then also we have Steve also taking the second class. So he's taking both classes. All right. So we have two different sets. Now, let's say I want to know all the students who are taking either class one or class two, either one. So I'm going to use add all. So I'm going to put here system out print line S1 add all. I'm sorry, TS1 add all. TS2. So that's going to give you basically the union. The union, that means basically both, all the students, whether they're taking first class or second. So I'm going to put here union. So if I run the program here, it's going to show me all of them, but without duplicates. So here, so here we see TS1 and TS2. Right? So here we have TS1 and then we have TS2. So add all TS2 and see. Yeah. See Bob, David. Okay, we have Bob, we have David, we have Mike and Steve. So add all. Okay, now we'll print. Okay, so this is TS1. Add all. So now what happened is all of them now they are in TS1. If I print TS1, TS1, it's going to show all the students, but it's not going to affect TS2. TS2 is still made of Maria, Jasmine, Mike, John, and Steve. But TS1, due to this operation, TS1 add all, so all the students, whether they're taking class one or class two, will be in TS1. So it's going to affect TS1, but not TS2. So if I run the program, look what the TS1 is going to do. It's going to show all of them, Bob, David, Jasmine, of course in order because we are using TreeSet. But if you print TS2, it's not going to change. It's the same student, which is Maria, Jasmine, Mike, John, and Steve. Right? So if I put TS2, you will see that it is the same people. See, Jasmine, this, of course, it has to be in order. Jasmine is first, John, then Maria, Mike, and Steve. See, so that's what add all does. Okay, it adds them up. Basically, it's find the unit. So now let me put this as a comment. Now we have another operation called for the intersection. It's called retain all. So if I put TS1, retain all, it's going to be with the intersection. What do you mean by the intersection? So the intersection is the list of students who are taking both classes. You can find them in class 1 and in class 2. Now, when we print TS1 and TS2 after this operation, let's see. So look at the TS1. It's going to show only the students who are taking both. Mike. So Mike and Steve are the only one you can find in both classes, if you can see. So this is TS1, and then we have Steve repeated, and then also Mike. So only 2 students are taking classes. Now we have a third one. Let me also again save this. So we have another one called the difference. So let's perform that operation, and then we can see what difference, what's the purpose of using it. So if you have TS1, we use the method remove all. TS2. So now let me print TS1 and TS2, and then I want you to see, tell me what happened. What's the purpose of using difference? So here for TS1, we have Bob and David. So what happened? What is this Bob? What is this list? Bob and David. But if you pay attention, look at S1. S1 is made of Maria. I'm sorry, no, that's TS2. So TS1 is made of David, Mike, Bob, and Steve. And then TS2 is made of Maria, Jasmine, Mike, John, Steve. So basically, if you remove from TS1 the students who are taking the second class, okay, which are Steve and Mike, what do you have left? David and Bob. That's the difference. So the difference basically is the removing the elements that are in the other set and then leave the rest. So that's basically what remove all does. That's the difference. Okay. All right. I hope you find this video useful. In the next lecture, we are going to talk about the map interface. So we'll talk about the hash map and the tree map. All right. Thank you.